Today we're going to talk about naming branch chain alkanes. And here are the rules or the checklist that you should be doing when naming or writing these things out. So let's go ahead and go over these real quickly here. Number one says find the longest continuous carbon chain in the molecule and use the name of that chain as the parent name. So whenever we draw or write out our names for these alkanes, we want to make sure we know what is the longest chain. We'll do some examples of that here in a moment. And some examples are like propane, butane, pentane, hexane, heptane, octane, nonane, and decane. And I'll make sure that whenever we're doing these, that we won't get any larger than decane. And if we do, then I'll give you that parent name. But for practice, or for all practical purposes, we don't need to get any larger than decane. Number two, if two chains are of equal length, choose the one with the larger number of branch points as the parent. So we'll look at that here in a few minutes, so some examples. Number three, the number of atoms in a chain beginning at the end near the first branch point. Again, that'll make sense when we do an example. Number four, identify a number of the substituents. Assign a number according to its attachment point on the parent chain. And what we want to be doing is looking for the smallest number of values when doing this. So when we get a chance to look at some chains. Number five, write the name as a single word. And we'll use hyphens to separate the various prefixes and commas to separate the numbers if there happens to be more than one alkyl group assigned to a carbon. B, if two or more different side chains are present, list them in alphabetical order. And the types that we're going to be talking about today are the methyl groups, and that is a single carbon. Ethyl groups. We'll have propyl groups, and the biggest one we'll have is butyl group. Okay. So when we look at naming these are our options, and obviously the B would come before the E would come before the M, and the M would come before the P, if we would happen to have all four of these type of alkyls within the name. C, if two or more identical side chains are present, one of the prefixes, di, tri, and tetra must be used, and we'll have an example showing that. And the last one, do not use the prefixes as a mode of alphabetizing. So these are what we're using to determine what we're going to alphabetize. So di, tri, tetra doesn't work. All right, let's do some examples and we'll refer back to these. So here's our first molecule, and what we want to do is find out which is the longest chain. Well, what's nice about that is it is a single chain. So we don't have to name or number any of these things. And what's nice about this is what we have to do is just call it what it is. So we have 1, 2, 3, 4, 5 carbons. And I'm not kidding when I say this. This is what we call normal pentane. So if there are no branches, and they're all single bonded, we just call that N-pentane for normal pentane. Well, that's a good one to start with. Let's look at this next one. Okay, let's go through the list here. So again, find the longest continuous chain in the molecule. If two chains are of equal length, choose the one with the larger number of branch points. Well, you could either say that I have 1, 2, 3, 4, 5 carbons here. That could be considered the chain. Or I could do that. Now, the bad thing is, in this case, it doesn't matter because they're both 5 carbons. So our root is going to be pentane regardless. That's our longest chain. But we want to number this accordingly. So when we number our carbons, we want to start numbering where we have our closest branch. So if I'm saying this is the chain or this is the chain, doesn't matter which, just make sure you choose one. If I'm going to do this, I can say, okay, there's my number 1 carbon, there's my number 2 carbon, number 3, number 4, number 5. So there is my numbering, because what I would not do is I would not number 1, 2, 3, 4, 5, because the branch is closest to this carbon rather than this carbon. So the top numbering would be a bad numbering system. So we don't want to use that one. We want to get it where the number is lowest to where the nearest chain is. So in this case here, on our number 2 carbon, we have a alkyl group, and this is a methyl group. So the way you would name this is I have 2, because 2 identifies where that group is at, 2-methyl, and since there's only 1, we don't have to do anything special to that, and then we'll bring that over, and the name of this compound is called 2-methylpentane. Looking at this compound here, we want to find our longest chain. And so if we said, oh, okay, we go here, that's our longest chain, it actually is not. Our longest chain goes here and there. Now, do realize that we have 1, 2, 3, 4, 5, 6 carbons as opposed to just 5 here. So identifying the longest chain in our molecule gives us our root, which in this case is hexane, because hex meaning 6. Okay, so now that we know who our longest chain is, now we want to number these. So again, we start numbering the chain. We would not start here because that would be 1, 2, 3, 4 carbon versus a 1, 2, 3 carbon. So numbering looks like this. Okay, so 6 carbons, that's why it's hexane. Our methyl group is attached to this carbon here, so we have a 3-methyl hexane group. Okay, so that's the name of our compound for that one. All right, looking at this one, find the longest chain, and sometimes the longest chain isn't just this guy here with a ethyl group and another ethyl group, but actually we have this as our longest chain. So there could be a couple turns, bends, and whatnot, so identify the longest chain, and then from there it gets a lot easier. So just because the structure looks like that doesn't mean that this is actually an ethyl group attached to this carbon here. Actually, it's just a weird way of actually representing it. So there's our longest chain, and what do we have? 1, 2, 3, 4, 5, 6, 7, 8. So our parent is an octane. Okay. And so we number the carbons accordingly. And our one and only group is right here. So now we can number it. So 1, 2, 3, 4, 5, 6, 7, and 8. So there's where we get our octane. And since there's only one methyl group attached to here, it's on the number 3 carbon. So it's a 3-methyl. Methyl, put an L in there, methyl octane. Okay. Here we go. Now we're getting into some fun ones. So find your longest chain. And you can experiment and say, okay, if I go this way, that's my octane. If I go this way, I actually have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So this is my longest chain, where I have an ethyl group here, and I have a methyl group here. Okay, so that's what you want to do kind of when you draw your chain, kind of identify your groupings that are branched off of that. So here, got that. Actually, erase that too. So when numbering this out, again, where's our first branch? Well, if we went this way, it'd be 1, 2, 3, 4. So we'd have an ethyl group on the number 4 carbon, or we go 1, 2, 3. So our first branch is on the number 3 carbon. So we want to start numbering on this side. 4, 6, 7, 8, and 9. And so if we have a 9 carbon chain, that's nonane. Okay. And now we have an ethyl group as opposed to a methyl group. So our ethyl group is on the number 6 ethyl. Okay. And we also have a methyl group that is on the number 3 carbon. 3-methyl. Okay. So I can either put the 3-methyl in front of the 6-ethyl, which would not be correct because we have M before E. So the methyl group needs to go here. The ethyl group will go here. And since we have more than one group, we'll go ahead and put a dash separating those. So we have our functional groups, okay, or our groupings here, our keel groups. And so the name of this compound is called 6-ethyl-3-methyl-nonane. Now, next week you'll have a chance to actually take the name and construct something similar to this. Now yours might not look as clean as that. It might actually be a straight line with the ethyl group down here and the methyl down here. We'll get a chance to do that a little bit later on. All right, let's take a look at this one. Find the longest chain. And it looks like it could either be this or it could be this. And it doesn't matter which way you're going. To be honest, it doesn't matter because, again, on that carbon, we're going to have an ethyl group and a methyl group attached, and on this carbon, we'll have an ethyl group. So we actually have two ethyls that are actually on this compound. So let's go ahead and number it because we are looking at our longest chain. So again, 1, 2, 3, 4 would be our ethyl. 1, 2, 3 would be our ethyl and methyl. So we're going to start numbering from this side. Okay, so we still have our nonane. Okay, and again, our groups. Here we have an ethyl group here, an ethyl group here. So we actually have two ethyl groups and our methyl. So what we'll do is, actually let's zap that one. That's an ethyl, and here's a methyl. Okay, it's nice to have the smartboard where I can colorize this. So on my ethyls, I actually have a 3 and a 6. So 3, 6. And since there are two ethyl groups, I'm going to say that that's diethyl. Okay. Now remember, the di does not take precedence over, say, just a regular methyl or whatever. So we don't consider the di-tri or whatever for alphabetizing. Okay. So we'll put that there. And then we also have a 3-methyl. So our 3-methyl group. And so make sure that we're alphabetizing this correctly. So the ethyl goes before the methyl. So we'll put that there. And we'll put that right there. And since we have more than one group, put a dash in between there. So in this case, this compound is called 3,6-diethyl-3-methyl-nonane. I think I have one more example, but I might make up another one here. And I do have one correction I need to make. This hydrogen is not there, so apologize for that. That hydrogen is not present, so it's just CH3CCH3. All right, so find the longest chain, and it looks like it's going to be here, there, or again down there, whatever path you want to take. So in this case here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons, and that's probably as ugly as I'm going to make it. So we'll have our decane. Okay, so we have our decane as our parent. Let's identify our groups here. So we have, it's like we have a methyl here, a methyl here, a methyl here. So we have 3 methyls. We have a ethyl here. And we have, yeah. Can I change color? Maybe I can. Let's see. Let's go with that color, whatever that is. Okay. And that color is going to represent a propyl. Okay. So there's our propyl group. So let's write down, actually let's get our numbers here. Let's zap that. Gone. So let's number these, and where should we start numbering? Start numbering up here or down here? If we do that, we go 1, 2, 3, 4, 1, 2, 3. So we're still starting up here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's our numbering. So let's go ahead and get that color back. Okay, so I've got a propyl on the 6, a propyl group on the 6. I have 3 methyls, so I have a 3, a 7, and a 7. So a 3, a 7, and a 7 on the methyls. And this is, since I have 3 methyl groups, this is trimethyl. Okay. And we also have an ethyl group, which will be green. So the ethyl is on our number 3 carbon. I think that's our only ethyl. So we have our ethyl, our 3 methyls, and our propyl. Okay, so now when writing the name of this, okay, let's move decane down here. Alphabetical first, so we have propyl, ethyl, methyl. So propyl goes right there. The methyl is next, and it goes right there. And then the ethyl goes right there. And it's nice to have the different colors, so we'll put dashes in between there. So the name of this compound is 3-ethyl 377-trimethyl 6-propyl decane. Let me make up one more. Okay, let's try this one. And go ahead and pause the video for a moment and try to work this one out without watching me ahead of time. Okay, I'm going to assume you've had a chance to try this one out. So let's go ahead and find the longest chain here. And by looking at it here, I'm going to say that might be the longest chain. 1, 2, 3, 4, 5, 6. Okay, that's an option. If I go this way, 1, 2, 3, 4, 5, 6. So that's another option where I can go this way or this way. Okay. Or I could go this way, still 1, 2, 3, 4, 5, 6. So there's many options that you could choose. Just to keep it simple, I'm going to go ahead and use that as my parent, just so you can see the other groups a lot easier. All right, so find the one that has the nearest branch. So that carbon's a number 2 carbon. If I went this way, that'd be a number 3 carbon. So we're going to number from this side. 5 and 6. Okay, and let's identify our groups, where we have a methyl group here and a methyl group there. We have, looks like an ethyl group here and an ethyl group here. All right, so let's go ahead and name this thing. So we have our 6th chain, so that's hexane. Alrighty, and what we also have is a 2, 2, and we have 2 of those, so that's dimethyl. Okay, so 2, 2 dimethyl. Actually, let's write that all in one thing there. So 2, 2 dimethyl. Okay. And we also have 2 ethyl groups on the number 4 carbon, so we're going to go 4, 4 diethyl. Okay. So let's do that. So 4, 4 diethyl. Okay. So here's our groups and our parent. So again, make sure that we don't consider the dis, tris as part of the alphabetizing system. So we're going to put the dimethyl right next to the hexane, and then we'll take the 4, 4 dimethyl, put it right there. So when we look at this compound, we have 4, 4 diethyl dash 2, 2 dimethyl hexane.